Today in class we talked about completing the square. So we're going to go over what was completing the square, what was the point of completing the square, and how do we do that. Completing the square comes from the fact that if you have something easy like this, x squared equals 16, you can take the square root of both sides, x equals plus or minus 4, and we know that. So we can complete the square pretty easily. What's interesting about completing the square, what the idea is, if you have a perfect square on one side of your equation, then the perfect square where the variable is. If you have a perfect square variable equals some number, this number has to be positive. It can't be negative, obviously. It could be 0, but it can't be negative. If you have a perfect square equals a number, then you can just take the square root of both sides and you're done. So we said that in class. If you have a perfect square equals something, you just square root both sides and you're done. Square root both sides and you're done. Well, what happened is we figured out that we can turn quadratics into perfect squares. So you can take something like this, x squared plus 10x equals 20, and we can turn this into a perfect square. How can we turn this into a perfect square? Well, we say, okay, I can turn this part, this left side, into a perfect square binomial, perfect square trinomial, which will factor into a perfect binomial, perfect square binomial, by adding something right there. Well, what can we add? What we'll do is we'll take this 10 divided by 2 and we'll square it. 10 divided by 2 is 5, squared is 25. Okay, now we have this is a perfect binomial squared, and we'll see that in just a second. If you add 25 to this side, you also have to add 25 to this side, so we'll do that. And now what we can do is we can actually solve this thing. This left side, factor that into x plus 5 squared equals 45. This is a perfect square now, and we just said if you have a perfect square equals some number, we'll square root both sides. So we'll square root x plus 5 equals plus or minus radical 45. Subtract 5 to the other side. X equals negative 5 plus or minus radical 45. The only thing we check now, this is our solution. We just check and see if we can simplify the radical. It turns out we can, because 9 goes into that. So it's actually negative 5 plus or minus 3 radical 5, and that's simplifying that radical. So our solutions are negative 5 plus 3 radical 5 and negative 5 minus 3 radical 5. And that's the idea behind completing the square. We can take something that wasn't a perfect square up here and turn it into a perfect square by adding 25. We can factor into x plus 5 squared and square root both sides. And we have a perfect square, we take square root both sides. So that's the idea. We want to turn something into a perfect square. We noticed in class, though, today that we need two things to be true to be able to complete the square. What we need is the x squared term to have a 1 coefficient. Had to have that. So we have to have the x squared has a 1 coefficient. And we want to move the constants to the other side. And if we do both that, then we can complete the square, constants to the other side. So let's work out a couple. I'll actually do a couple problems off the homework so that we can get an idea of how to do this. The first one that I'll look at is number 13 off tonight's homework. I'm on page 460. 13 says r squared minus 2r minus 35 equals 0. I want to solve this quadratic. And I'm going to solve by completing the square. So I check my checklist first. Does the x squared, does the squared term have a 1 coefficient? Yep, that's a 1. Have I moved the constants to the other side? Not yet, so I'll do that. I'll move the 35 to the other side. So I have r squared minus 2r equals 35. Okay, now what do? Well, what I'm going to do is I'm going to take half of this. Well, I want to fill in this dot. So I take half of this guy. Half of negative 2 is negative 1. And square it. Negative 2 over 2 is 1. Squared is 1. So we add 1 to both sides. I have to add 1 over here. This gives me, this is a perfect square now. That's r minus 1 squared equals 36. This is a perfect square. This is a number, so I take the square root of both sides. R minus 1 equals plus or minus 6. Add 1 to both sides. R equals 1 plus or minus 6, which means r equals 7 or r equals negative 5. And those are my two solutions by completing the square. All we did, the main trick, make sure you get that number there. If you get that, then you can factor, you can square root, and it's easy after that. Let's try another one. Let's try one that won't work out as nicely, or maybe one that's just kind of weird. How about 17? M squared plus m minus 28. equals 0. Okay. Is this a 1 in front of the squared term? Yes. Now I move the constant to the other side? Not yet, so I'll do that. M squared plus M equals 28. Here we go. I want to complete the square. What do I add here? I don't know. Take half of this number. 1, half of that, squared. Half of 1 is a half, squared is a fourth, so I'm going to add a fourth to both sides, add a fourth to both sides. I get M squared, sorry, I want to factor this now. So I'm going to get M plus 1/2 squared equals, and over here I want to actually get, what is this number? So I'm going to get a common denominator, so I'm going to put this over 4, which will give me 112, 2, 3, 8, 9, 10, 11, 112. So 112 over 4 plus 1/4. This will actually give me M plus 1/2 squared equals 113 over 4. And then perfect square on this side, take the square root of both sides. M plus 1/2 equals, I can take the square root of 4 but not 113, so I'll put that all over 4. Sorry, all over 2. Square root of 4 is 2, come on now. Minus 1/2, minus 1/2, this is plus or minus. I get M equals negative 1/2 plus or minus radical 113 over 2, and rules of addition and subtraction, actually write that all over the same denominator. M equals negative 1 plus or minus radical 113 all over 2, and I have that problem completed. Takes a little bit of work, there's fraction work, the square roots, the whole deal on that, and it does take a little bit of work, but it's not really that hard. As long as you complete the square, all the rest of the steps after that are basically the same. We'll try one more, and then the rest you can do on your own. So we are going to try, the last problem we're going to try is, how about 33? Why not? 33. 3d squared minus 24d equals 3. Okay, first thing to check, is that a 1? No, it's not, so divide everything by 3. Just divide by whatever number's there. You have to make that a 1, you gotta divide by whatever's there. D squared minus 8d equals 1. Okay. I want to, all my constants are over there, so now I just want to add something there to complete the square. Half of this number squared, that's negative 4, squared is 16, plus 16. D minus 4, because I factor this side into a perfect square, equals 17. Square root both sides. D minus 4 equals plus or minus radical 17. Ask yourself, are you done? No, you don't have D by itself. Add 4 to both sides. D equals 4 plus or minus radical 17. And now you're done. The rest of the problems I'm going to let you work out on your own tonight. They shouldn't be too bad, really, as long as you follow this, and now you have enough examples to do this.